Hi, I'm Tilda. I'm a self-taught developer with a passion for Python. If statements. So far, we've learned to create expressions, use variables, and make our own functions. Our next step is to learn how to write code that will only run based on a certain condition. For example, we may want to draw game over text on the screen, but only if the player has run out of lives. To do this, we need to learn how to use an if statement. The if statement is also known as a conditional statement. You can use the term conditional statement when you want to impress everyone how smart you are. The if statement allows a computer to make a decision. Is it hot outside? Has a spaceship reached the edge of the screen? Has too much money been withdrawn from the account? A program can decide which block of code to run based on this statement. Basic comparisons. Here are two example if statements. As you can probably guess, the statements see which variable is smaller and which is larger. Try running the code. You should get output that looks like this. Since A is less than B, the first statement will print out if this code is run. Flip the values and the second statement will run. If both variables A and B were equal to 4, then neither of the two statements would print because 4 is not greater than 4. Play around with the program by adjusting the values to verify the code continues to do what we expect. Flowcharts. To show the flow of a program, a flowchart may be used. Most people can follow a flowchart even without an introduction to programming. See how the flowchart below matches with the code we just ran. If statements go in diamonds and have two possible paths out of them. Regular statements go in rectangles and have only one exit path. This book skips an in-depth look at flowcharting, but if you're curious and want to learn more, Wikipedia has a great article introducing how it works. More comparison types. The prior example checked to see if variables were greater than or less than. Numbers that were equal would not pass the test. To check if values are greater than or equal, we use the two characters greater than equals right next to each other with no space between. Let's adjust our prior code sample. The less than equals and greater than equals symbols must be used in order, and there may not be a space between them. For example, equals less than will not work, nor will less than space equals. When writing these statements out on actual paper, some new programmers like to use the less than or equal symbol because that's what we learned in math. For example, this less than or equal symbol doesn't actually work in a program. Plus, most people don't know how to type it on the keyboard. Just in case you're curious, to type it, hold down the Alt key while typing 243 on the number pad. So when writing out code, particularly on paper, remember to use the two characters less than equals and not the one character less than or equal symbol. If you encounter a written test or quiz, make sure to write it out correctly and not lose points. The next set of code checks to see if two items are equal or not. If we want to check for equality, we use two equal signs in a row. Equals equals. The operator for not equal is exclamation point equals. Here they are in action. Add them to the bottom of the other code we were working on and try them out. Attention! Learn when to use equals and equals equals. It is very easy to mix up when to use equals equals and equals. Use equals equals if you are asking if they are equal. Use equals if you are assigning a value. The two most common mistakes in mixing the equals and equals equals operators are demonstrated below. Stop. Please take a moment to go back and carefully study the last two code examples. Save time later by making sure you understand when to use equals and equals equals. Don't guess. Indentation. Indentation matters. Each line under the if statement that is indented will only be executed if the statement is true. In this example, the 3 lines indented under the if statement will run only if true. The 4th print statement will always run because it is not indented under an if statement. The indentation amount must be the same. This wandering code doesn't work. Once an if statement has been finished, it is not possible to re-indent to go back to it. The test has to be performed again, so this code example doesn't work at all. If you try running it, you'll get the following indentation error. Using and or. An if statement can check multiple conditions by chaining together comparisons with and or. These are also considered to be operators, just like the plus and minus characters are. Go ahead and create a 3rd variable c and try using these 2 new operators yourself. Hint: repeat yourself, please. A common mistake is to omit a variable when checking it against multiple conditions. You cannot write if a less than b or c. Neither will if a less than b or less than c work. The computer does not know what to check against the variable c. It will not assume to check it against a. You need the full if a less than b or a less than c for it to work correctly. Boolean variables. Python supports Boolean variables. What are Boolean variables? Boolean variables can store a value of either true or false. Boolean algebra was developed by George Boole back in 1854, well before electronic computers. Yet his work forms the basis of how computer logic works. If only he knew how important his work would become. An if statement needs an expression to evaluate to true or false. What may seem odd is that it does not actually need to do any comparisons if a variable already evaluates to true or false. For example, in this code we set the variable a to true. Our if statement doesn't need a comparison. If a is true, it will execute the statement. If it is false, it will not. Another operator we can use is the not operator. You can take any statement or boolean and flip between true and false. The statement if a runs if a is true. The statement if not a runs if the statement is false. It is also possible to use Boolean variables with the and or operators. Attention! Who knew true-false could be hard? It is also possible to assign a variable to the result of a comparison. In the code below, the variables a and b are compared. If they are equal, c will be true, otherwise c will be false. Hint: 0 means false, everything else is true. It is possible to create an if statement with a condition that does not evaluate to true or false. Because this is confusing, we don't use this fact a lot, but it is important to understand how the computer handles these values when searching for problems. These 2 examples will run and will cause the text to be printed out because the values in the if statement are non-zero. The code below will not print out anything because the value in the if statement is 0, which is treated as false. Any value other than 0 is considered true. The input function. Rather than hard-coding values into a program, we can use the input function to ask the user to type something in. The input function is reasonably simple to use. As a parameter to input, just give it text to use as a prompt. Whatever the user types in is stored in the variable on the left. Note that there is a question mark and a space at the end of that string. If you didn't have this, what the user types in will run right up next to the prompt. That looks terrible. The user is tempted to type a space as the first part of the input, which complicates things for us later. There's one more thing we have to learn. We can't take what the user types in and compare it to a number. This program will fail with a type error. Whatever the user types in is stored as text. We also call text a string because to the computer it is just a string of characters. This is different than a number, and the computer does not know how to compare them. Therefore, we need to convert the input into a number. We can do this with the int function for integers. If we have floating point numbers, use the float function. In this example, we get the input, convert it to an integer, and then we can use it in an if statement. You can chain the input and int functions on one line if you like, as shown here. Else and else if. So far, we've used simple if statements to run a block of code or not run it. What if we want to select between two blocks of code? What if we want to run one of 4 different blocks? To do this, we need else or else if logic. Let's start with a simple if statement that prints if it is hot outside. If the programmer wants code to be executed if it is not hot, she can use the else statement. As for indentation, notice how the else is lined up with the I in the if statement. Also notice how else is followed by a colon just like the if statement. Try running this code. The if statement will always run one of the 2 blocks, but never both. In the case of an if-else statement, one block of code will always be executed. The first block will be executed if the statement evaluates to true. The second block if it evaluates to false. It is possible to chain several if statements together using the else if statement. Python abbreviates this as elif. In this example, we add a third possible combination using elif. In this next example, we've made a mistake. The program will output, "It is hot outside," even if the user types in 120 degrees. Why? How can the code be fixed? The computer doesn't do a best fit. It looks at the if statement in order. As 120 is greater than 90, it will run the first condition and skip the rest. To fix this code, we need to reorder it. Text comparisons. It is possible to use an if statement to check text, as shown in this example. The prior example will only match if the user enters Paul with a capital P. It will not work if the user enters lowercase Paul or uppercase Paul. A common mistake is to forget the quotes around the string being compared. In this example below, the computer will think that Paul is a variable that stores a value. It will flag an error because it has no idea what is stored in the variable Paul. Multiple text possibilities. When comparing a variable to multiple possible strings of text, it is important to remember that the comparison must include the variable. For example, instead the code should read like this. Confusingly, the first example will run, but it will always trigger the if statement even if the name isn't Paul or Mary. This is because for any value other than 0, the computer assumes to mean true. Mary isn't 0, so to the computer, Mary is the same thing as true, and so it will run the code in the if statement. Case-insensitive comparisons. If the program needs to match text and we don't care if it is upper or lowercase, we need a case-insensitive comparison. The easiest way to do that is to convert everything to lowercase, then compare. This can be done with the lower command. The example below will take whatever the user enters, convert it to lowercase, and then do the comparison. Important, don't convert to lowercase and compare it against a string that has uppercase, then you'll never match. Review. With the introduction of if statements, we've learned how to run code only if a condition is true. By adding in elif and else statements, we can run one of multiple possible code blocks depending upon a condition. We've learned that we write conditions using comparison operators, like less than and greater than. We've learned that equals equals is the comparison operator for asking if two items are equal, while equals is the assignment operator used to set a variable's value. We can reverse logic using the not operator. Finally, we were introduced to boolean values, where variables can store true or false. The if statements can operate based on those values.